In today's lesson from Unit 2.2, we're going to learn two more shortcuts for proving triangles similar to one another. Now, if you recall, in our last lesson, notes number 3, we discussed a shortcut called the angle-angle similarity. And that worked because we were able to prove that two angles of one triangle were congruent to two angles of another triangle, and that's enough for us to say that the two triangles are similar. So then we can set up proportions, write similarity statements, solve for missing sides, etc. So today we're just going to jump right in and talk about our first shortcut, and it's called the side-angle-side similarity theorem. And it says if an angle of one triangle is congruent to an angle of another triangle, and the sides including those angles are in proportion, then the triangles are similar. Now check out how this is set up in our picture right here. We see that angle B, I'm just going to highlight this in red, is congruent to angle T because they're both right angles. And then we see that the sides that include the angle, meaning the two sides that make up the angles, side AB and side CB in this case. And in the second case, it would be side UT and side ST. So check it out. We have side, angle, side, and side, angle, side in the other triangle. Now, remember, we're not proving triangles congruent to each other. We're proving the triangles are similar to one another. So what we need to say is if we compare the sides, so if 3/6, comparing the shorter two segments to one another, is equal to 4/8, and it does, because we get 1/2, and angle B is congruent to angle T, then triangle ABC is similar to triangle STU by the side-angle-side similarity theorem. Okay, so keep in mind one thing. Up here, we're proving the sides are proportional. Okay, and the other thing to keep in mind is we really need to be careful when we write the similarity statement. So if you check out how I named the first triangle, triangle ABC, I went along the shorter side in this triangle, so I need to follow that pattern in the second triangle and go with STU. Okay, now it's your turn. Draw your own example of the side-angle-side similarity theorem. You can't draw a right triangle though, I've already done that, and you can't use the scale factor of 1:2 or 2:1. That's what I used on that first example. So try one on your own. Okay, just in case you couldn't come up with one on your own, here's an example for you. So my first triangle, I'm going to call it triangle ABC, just to keep it easy. And I'm going to tell you that this angle is 110 degrees. And these two sides are 8 and 16. And notice how I'm using the sides that make up that angle. So that's side, angle, side. Okay. Now here's my second triangle. And again, I'll keep it pretty easy. We'll call it triangle DEF. And so I'm going to tell you that this angle is 110. This side is 12, and this side is 6. Okay, now certainly this pair of corresponding angles are congruent, so that's one check, one thing that we have to check in order to say our triangles are similar. Now let's compare the sides. Now, when you compare the side lengths, all right, don't worry about how I drew the triangles here. We want to compare the shortest segment from this triangle, which is 8, to the shorter segment labeled in this triangle, which is 6. Now 8/6 would reduce to 4/3. Now we have to compare the other pair of corresponding sides, 16 and 12. So we want to compare shorter side to shorter side, longer side to longer side. If we check this out, notice that this is also going to reduce or simplify. Take and divide by 4. 16 divided by 4 is 4. 12 divided by 4 is 3. And we have the same ratio in both cases. So since they both reduce to 4 to 3, then our two triangles are similar. Now, when we name the first triangle, you can go ahead and name it triangle ABC. Just be careful when you name the second triangle. Remember that this side length labeled with 8 corresponds to this side length over here labeled with 6. So triangle ABC would be similar to triangle FED. If you wrote triangle DEF, just based on what the triangles look like, unfortunately that would be incorrect. Okay, and these two triangles are similar by the side angle side similarity. So remember, this is what's referred to as a similarity statement for the two triangles. Okay, our last shortcut for proving triangles similar to one another is called the side-side-side similarity theorem, or just SSS similarity for short. And it says if the sides of two triangles are in proportion, then the triangles are similar. So in this shortcut, we don't have to know anything about the angles. All right, we're just comparing the sides. So what you want to do is compare the sides from shortest to longest. So because we're comparing three sets of sides, let's just quickly set up three ratios. So in our smaller triangle, we have side lengths of 3, 4, and 5. So I put them in order from smallest to longest. And in the bigger triangle, the side lengths are 9, 12, and 15. Okay, again, you've got to do it in order, either from longest to shortest or shortest to longest. All right, take a second and reduce all of these fractions. 3 over 9 would simplify to 1/3. 4 over 12 simplifies to 1/3. And 5 over 15, what do you know, simplifies to 1/3 as well. Since we got the same fraction every time, the two triangles are similar to one another. So let's write our similarity statement. Triangle ABC similar to, and if you name that second triangle MNP, you are correct. And they're similar by the side-side-side similarity theorem. Okay, good luck on the CYU. Please speak up if you have any questions. Make sure that you check your work frequently just to be sure you're on the right track. Good luck.